So next is how actually the threads run. That is, the CPU gives time to each thread so simultaneously that so frequently that we feel as if all the threads are getting executed simultaneously, but no threads are executed simultaneously, as we know that no process is executed simultaneously. What happens is context switching. Context switching means, so the one thread is given with the lock and the other thread is waiting there. That is, the context switching happens where the operating system takes care of moving the threads, moving between the threads. Only one thread is executed at that time and the other thread is actually just waiting for the CPU. So that is how it is executed. Okay, next is we'll go into the in detail about practically how do I create thread. So what are the different methods of creating thread? So there are actually two methods of creating thread. So one is by extending the thread class. The other method is by using the runnable interface, by implementing the runnable interface. So as I told, Java supports directly for this all threads and multi-threading and all. So that means there is a class called thread, T-H-R-E-A-D, that is T starts with capital T. So that is the thread class. So the thread class can be extended and I can create my own different threads. That is, as I told, main method is also one single thread. Actually main method is also considered as one single thread. So like that, like the main method, I can have my own different methods, I can have my own different classes, so which can extend the thread class. Like this I can execute multiple threads. By that I can achieve multi-threading. So the first method is the extending the thread class. So here what we do is, there is a run method, there is a start method. So all these methods are there in the thread class. What are we doing here is, by extending the thread class, we are going to override the run method and the start method. So what I want to execute, what I want to do, what is the task that I want to do, so that is written inside the run method, and then I can make that execute by using the start method. So start method is something like a switch to the run method. I execute that start method, only then the method, that is the run method, executes. So that means with an example, if you go, so here there is a class called multi-threading demo, which is extending the thread class. So once I say that I am extending the thread class, automatically I can use the run method and the start methods. So that means I have written a run method here. Inside the run method, I have just a print statement which says that my thread is in the running state. So, and then I close all that class. Next, I create one more class, that is the main method class. In the main method, what I do is, I create the object of the multi-threading demo. That is, multi-threading demo is the class which I have defined earlier. So that class object is created, and using that object I call the start method. That's what I told just now. That is, the start method is something like a key, something like a switch to the run method. So once I execute this start method, once I invoke this start method, automatically the run method executes, and what I want to do, that is what's the task that I want to do, so that is written in the run method anyhow, and that gets executed. So that this is one method where we extend the thread class. The next method is, so just as the thread class, it is also the same thing, only thing is the way is different. That is, by implementing the runnable interface. As we know that we can extend a class, otherwise we have to implement an interface. So interface is implemented and class is extended. So like this is just another example of implementing the runnable interface. So here also we are taking the same example of multi-threading demo, which is implementing the runnable interface, and that runnable starts with capital R, and that's also interface which is already there. So that interface also has the run method, and we are overriding that run method. So in the run method, again I am writing the same text, that is my thread is in the running state. And then the multi-threading class, the multi-threading test, what we have defined. So there we have the main method. In that main method, this is just indirect one where I create an object of the multi threading demo, that object is passed to the thread class. So we can see it's just an indirect method, that's all. So the thread class gets the object of this multi-threading demo, and that object, that is the thread class object what you have, so that object is used to call the start method. So just an indirect method of doing the thing, otherwise both are same. That is, the creating multiple thread is as simple as creating objects. You can create any number of objects and you can make those objects call your runnable interface, call your thread class. That is, thread class is also implemented and runnable is also implemented. As and many objects that you create and as and many classes you create which are extending the thread class or which are implementing the runnable interface, so those many threads I can start creating, and those many starts I can start using, and by that I can achieve the multi-threading. So it's very simple as creating just objects. So how do all the threads execute? So the question arises that when all have same priority or all are same, so then how do the operating system takes care of executing all the threads simultaneously? So there we can set the priorities. So say for example, I want one of my thread to execute with the highest priority. I want this thread to execute with highest priority. So there what I can do is I can set priority for my thread. So set priority is a method that is available in the thread class. So using that I can give a priority to my thread. That is, it starts with number, that is the numbers is something like 1, 2, 3, 4, 5, 6 up to 10 I have. Higher the number, higher the priority. So like that I can set the priority and I can make the thread execute with the highest priority. Of course it's obvious that the thread having highest priority will execute first, the thread having the normal priority will execute later, and the thread having the least priority will execute last. So that's obvious. So next is when we see that all the threads are executed simultaneously when I don't have any priorities, that is I have not set any priorities and all the threads should execute one after the other, one after the other. So that's not the case. That is, I said operating system does the context switching deliberately from one thread to another thread, and user will not be knowing anything about that. That is, which thread is executed first, which thread is executed last. That is this program what we had seen just now. So if you execute that, you get outputs, that is different outputs each time. You cannot be sure about the outputs that you get. So that's what we mean by the threads are switched between one another, so just randomly. And when this happens, there are problem like there is one file, one thread is writing into this file and the other thread is reading from this file. So what to do when both the threads are doing just randomly one after the other, one after the other? So there is a problem of inconsistency. One is writing into it, the other is reading it. So one thread is writing and the other is reading. So there, how can you ensure the inconsistency? So there is sure that we are going to get the inconsistency. So to solve such problem, we have the concept called synchronization. So synchronization is something like making two threads synchronized one after the other. That is, one will execute, it will rest, and the other is execute. That is deliberately no inconsistency is achieved. So that is what we mean by synchronizations. That is, we will have a lock and a key. If the thread has the key, it can open a lock. If the thread doesn't have the key, it cannot open the lock. So that's simple. That is, both will share the same key. Both will share the same key. So they will switch between the keys and they will start using the resource. That is, one single resource is being used by two different threads. So such situations, in such situations we come across with this synchronization concept. So there the process can be made synchronized. So as we have in the multiprocessing, so there also I can make the process synchronized. In the same way, in multi-threading, I can make the threads synchronized. So there, how do we provide a safe access to the data? So that is, the safe access to the data is given by declaring the methods synchronized. or otherwise declare in the class as synchronized. So by that we can ensure that there is least chances of inconsistency, there is least chances of deadlock to occur. So we know that one thread is waiting for one resource and the other is waiting for the other. So like this, if a cycle occurs, the deadlock occurs. So there, to avoid all such things, I can make my methods or class synchronized. So we'll just see one simple example of. So say for example, I have one balance, that is in my bank account I have a balance, and that balance is getting updated when I deposit some amount, and it gets updated when I withdraw some amount. So in both the cases, the amount is the only one variable which gets updated. So there I make two methods, that is updating, that is with the withdraw, updating with the deposit. So both the methods are made synchronized, that is the first is synchronized and the second is also synchronized. That is, by making both the methods synchronized, I can be sure that at a same time my amount, what the bank balance amount what I have, the variable, so it cannot go into the inconsistent state where it is getting updated randomly. So only after the deposit is done, I can know my balance to what is the amount that I want to withdraw. So in the same way, after I withdraw some amount, only after that the deposit will come to know that, or the deposit method will come to know that what should be the amount that I want to deposit to this account. So like this, you can see that the private variable float balance is what is declared, and the public synchronized method withdraw accepts amount as a parameter, and there I check and I deduct the amount what I want to withdraw. And in the synchronized deposit, what I can do is I can just add the amount to the balance. In both the cases, the balance is getting updated, and this balance updation is done systematically one after the other, not as before where the threads execute one after the other without any rules, without any convention. That is, synchronization, using synchronization will make the thread to be controlled, that is, the threads are controlled and they are executed systematically one after the other. So overall, looking at the review of what all I discussed just now is, we have divided the different tasks. So we have divided the different tasks, that is not different as one process and the other process. It is between single process we have divided different tasks. So that is what we mean by multi-threading, and Java supports multi-threading with so two different methods, that is by extending the thread class and by extending the runnable interface. So these are the two methods. And then again we saw we can set the priorities to the threads, and then the last one what we saw is the synchronized methods, where I can make my methods behave intelligently so that they will execute one after the other systematically, not causing any problems of inconsistency. Okay, so this was all about the multi-threading concept what I had to explain. In the next class we will continue with the next concept. Thank you.